All right, I'm not done with these problems, okay? So what we're gonna do is we are going to solve these problems for the exterior angle and try to figure out what that exterior angle is. I pointed at 15 because that's the problem we're gonna work on right now. And you are gonna work on 14 and 16. And while working on this, I figured out some pretty interesting things. So let's look at this triangle here. I'm gonna label each interior angle a certain letter, okay? So let's label them in yellow. All right, so I got this angle is going to be A, this angle is going to be B, and this angle here in the corner is going to be C. And the exterior angle that I just pointed out, we're going to call that D. Okay? Well, the triangle sums theorem says that I should be able to add A, B, and C, and it should get me 180 degrees. Okay? Well, so that's the triangle sum theorem. I'm also going to give you another theorem, okay? And that one is, well, I say theorem, linear pairs. Linear pairs are two angles that form 180 degrees or lay on a line, okay? And we can see D and C, they lay on a line right here. See, here's the line right here at the bottom. So both those angles are going to form that 180 degrees, okay? So by that, we're going to say C plus D are equal to 180 degrees. Okay, something you should know about linear pairs, they are also supplementary. All right, supplementary means they add and become 180 degrees. Okay. Oh my goodness, my drawing is off. But linear pairs are supplementary. They add to become 180 degrees. So that's how we're able to come to these conclusions. Okay? Now what we're going to do is we're going to do something kind of a little bit tricky. So what we're going to use is we're going to use that transitive property that we were talking about earlier. And we're going to set both of these equal to each other. Okay? So by the transitive property, this, since it's equal to 180, is equal to this because it's also equal to 180. So I'm going to say, oh, come on, don't confuse people. Do yellow. Hello. A plus B plus C is equal to C plus D. Okay? And that's the transitive property. Should I write that down? Yes, write that down. Okay? This is transitive property. Technically, property of equality. And I might not have spelled that right, but we'll see. Now, this is an algebraic expression. Let's solve this, or simplify this a little bit, because I see I have C both times here. So we're going to use this, the subtraction property. Green, let's pick green. We're going to subtract C from this expression and subtract C from this expression. That makes them both equal, and they stay equal. So that leaves me with B, A plus B. C minus C is 0, so that goes away. C minus C is also 0 on this side, that goes away, and that makes it equal to D. And that's by the subtraction property. Subtraction property? Yes, I'm going to put that down. That's the subtraction property of equality. Okay? All these properties are ever present in algebra and geometry. They just keep coming up over and over and over again. You have to learn them. And even when you go to college, they don't go away. They are there in calculus. They are there in linear algebra. They are always there. Okay? So let's try this. A plus B is equal to D. Well, now that I've simplified that, we know what A is. A is 24. Let's do this in group. So this is the substitution property. Okay, 24. B is 2x plus 18 plus 2x plus 18. And D is 3x plus 6. There's my substitution property. How did you know to use a substitution property? Because you can't lose sight of what your end goal is. Your end goal is to find that exterior angle. And the way I'm going to find that exterior angle is I use these properties to come up with some sort of expression that I can solve, because we've been solving expressions since hopefully before 6th grade, but by 6th grade you should have been solving these expressions. Now I'm going to have to zoom up because I'm running out of room, okay? But we're going to use that subtraction property. This is substitution property. We'll just, yeah, we'll do green again. No, we're going to do red. That's okay. All right, so this is substitution. Again, it gets so bad to write at the end of this. Okay, hold on, here we go, up we go. All right, so we're going to solve this. And the way you solve it is the same way you solve all equations, all right? So I'm going to have this expression here. I have a like term here. Over here, there's no like term, so we're going to combine our like terms first. So 24 and 18, so we get 2x plus 24 plus 18, that's 30, 42. All right, 3x plus 6 didn't change. This is all still equal because all I did was just combine them. All right, and I can write that. That property that we did is combining like terms. Next, I'm going to subtract 2x. I'm being strategic. I want to move all x terms or all terms on the same side that are like as well. So this becomes 0. So I got 42 is equal to 3 minus 2, which is 1. And then I'm going to subtract 6. Okay, again, subtraction property twice, so I'm going to subtract 6. Oh, yeah. And that should get me 36 is equal to x. All right? So that little variable x up there is equal to 36. So, all right. And then from there, you're going to substitute 36 into this expression here. So you're going to have 3x plus 6. We're going to substitute 36. And then you're going to simplify it. So this becomes 108, I think. And then plus 6 is 114. And so that exterior angle is going to be 114 degrees. And don't mind people coming and going all the time. So, again, we're using these properties, subtraction property, substitution, and then simplifying by multiplying, adding, and we finally come to the end. So it is a lot of work. However, it is very manageable because each of these properties you've been able to do independently. So now you just kind of put them together. All right, so good luck, and I'll see you in the next one.